Okay, this is the third video. So a wavefront is essentially is the top of a wave. It's the crest. It's an imaginary wave surface that looks like the crest of a wave. Okay, so if you're looking down on some ocean waves, you'll see the waves would have some sort of line to them. That's your wavefront. Okay, they're created from the fact that every point of a wave can be seen to be radiating in all directions. So let's say we have a wave front, so this is like the top of a crest of a surf wave. If you actually just look at one individual point, the wave energy would actually want to radiate in a circular fashion from that point. And the same from another point, it would want to radiate in a circular fashion. Now if you combine all these, you get only one line in the future. Okay, all these other lines here in between have been cancelled. Okay, so you're only left with this wavefront in the future. So the circular wave pattern, this is by the circular pattern will create a linear wavefront. Okay, but all you have to remember is that it essentially is just shows the straight line nature of a wave. So with reflection, using this principle, these are the wavefronts, like they're long crests. Okay, each point of this could be like a little beach ball. Okay, this one's going to come in, and this point here is going to bounce off and go up that direction. So this point here is going to hit and start going off in a new direction. That point there, okay, so what happens is the wave actually bounces off and heads off in a new direction like that. So reflection of water, so you've got a straight line reflection. Okay, so there's your boundary. You've got your waves coming in. They will hit and then just bounce back. Okay. Refraction, on the other hand, is sort of like, imagine you have some soldiers all attached by a line, and they walk forward. Now let's say we had some soft sand starting around about here. Oh, maybe a bit further down. So some soft sand starting around about here. So as these guys walk down, this guy is now in the soft sand. He's going to start walking slower. That guy's there, that one's there, that one's there. So a bit later on, this guy is now walking slower than these guys. So this guy will get left behind. He's only going to make it to there. That guy is going to sort of get slower too. This guy is just coming in, and so on. Okay, and so as we go in, we actually end up going off in a new direction. You get dragged around by the slow guys. And that's what happens in water. So as you go from deep water to shallow water, the speed of a wave slows down. Okay, so the speed of a wave drops as depth gets shallower. Okay. So speed goes down, and that actually means your wavelength is also going to go down. Okay? Frequency, there is no change. You can't have a build-up of waves, okay, if the frequency changes. i.e. if this was a tunnel and we had cars driving in and we had 1 car a second going in and 1 car per second going out, then it would match, okay? We would have an even number going in and an even number going out. However, if we had 5 cars per second going in and only 1 leaving, then we're going to get 4 extra cars building up inside, and you're going to start making a big tower of cars. So you actually need to keep the same frequency all the time. So deeper, shallower water, your wavelength gets shorter. You can see it. There's the wavelength compared to deeper water. It's much longer. And this is what happens when you get your refraction too. Diffraction is the bending of a wave through a gap or past a boundary. You can see it here in the water. So we've got waves coming in, and then it hits this gap and it starts spreading out in a circular fashion. And that's what happens here. And the closer the wavelength to the gap size, the greater the curving. Okay, so this wavelength there is about similar to the gap size. Okay, however on this one here, this wavelength is much smaller than the gap size, so there's only little curving here, and this one there is large curving. And it can also happen the opposite way. So what we have is, if you have shallow water around the top of this headland, then you'll get curving in towards the headland when the waves are coming straight in towards it.